Hello, I'm Mark Hurst from Canon Technologies, and I'd like to show you around a modular data center. This is a 20-foot entry module which goes on the side of, in this case, we start with 5 40-foot modules. That can be expanded to 8 40-foot modules. This can have any access control system you like on it to go into the space, RFID, biometric, whatever you desire. And this 20-foot module is used as a pre-production space, and it also allows you somewhere to take your wet weather gear off and change into whatever clothing you want to wear inside the data center, put on your slip-on shoes, etc. Come and have a look around. Here we are in the 20-foot entry space module. We've got the 2 doors off into the data rooms. We've got the first one through an entry pod, a man trap. And the second one is pedestrian access for server trolleys, etc. It's a large open space. We've got room in here for a pre-production cabinet, room to take your equipment out of cardboard, etc. and take it into the space. There's also a lot of room along this wall. We can have coat racks, boot racks, equipment racks and spaces, tool rooms. There's also access control systems, fire alarms, and mimic panels for all these devices are kept in this space, which is outside the protected area. We enter through a man trap into the white space. This is standard man trap seen in many data centers. You can have any access control system you like on it. It can be RFID, biometric or iris control, whatever system you desire. There's a little bit of small power distribution in this space. And we're in, as I say, the first cold aisle space, which is cooled by our within row units, which we'll be looking at in a moment. And there's access to our power modules, which are just to our left-hand side. At the end of each row, there's a power distribution cabinet. This has all the switchgear in it to distribute the overhead power, which is going to all the data cabinets down the rows. We have an A system and a B system, one at each end of each row. We enter into the power room through this middle door. This can be under a separate access control system or just be under lock and key to allow any authorised personnel into the power rooms. Welcome to Power Room A. We'll have a quick look around the power room system here. What we got, if we start right at this end, got the incoming terminals for our 1250 amp switchgear. So this switchgear can support up to 800 kilowatts of load within this footprint that you see in front of you. We have our incoming power terminals, our EPO. That's also repeated in all of the data modules. They all have a remote operation of the EPO. We have our incoming mains isolator. We then have our first loads. These are non-critical loads which connect just behind me. We have our generator inputs. We've got 2 generator inputs here, one for day 1 and 2, and a second one should it be required on day 3 to add a second synchronized generator. We also have a critical output, and these are used for life support systems, fire alarm systems, smoke extract, and those sorts of systems. The main power control system is up here. You select which type of generator mode you're running in. We've got mains fail test facilities, and we can also put it into an automatic or manual transfer mode should you wish to have the generator start manually for any reason. We then move on. We've got cable connections, and we've got our first outputs for our non-critical loads. These are our chiller outputs. And again, we've got a day 1 chiller output, day 2 and day 3. So all this can be worked on, all of this switchgear can be worked on in the live state. So we can add the day 2 chiller connections to the system. They're all fully isolated. So on day 2, we can just plug those in without having to turn off any of the critical systems. We then move into the outputs and bypass for the UPS. And again, all of this equipment can be worked on with the loads alive. You don't have to worry about isolation of these systems. So we've got our main UPS bypass, wrap around and return, all in these 3 or 4 panels. And you've got a trapped key so that the wrap around and bypass can only operate when the UPS has gone into bypass mode. The UPS then back feeds into the system, comes across, and this is our critical load. This is our data center load. They're on all these isolators. These supply end of row power distribution, which is at the end of each of the rows of cabinets. You've got localized power distribution. So we've got the outputs to the first row of cabinets, second row of cabinets, third row of cabinets, fourth and so on. All of this is power system A, and this is all repeated in power room B, which is just behind me. This is a 2N power solution or N+1, depending on how the client wants to run it. This room, and we've got the room behind us with the UPS we'll be looking at in a minute, this can support 850 kilowatts of load, which means the whole of these 2 modules can actually support 1.5 megawatts of power and critical load. Let's have a look at the UPS systems installed here. We've got again an A and a B UPS system with full total support. This is a 500 kilowatt frame or 500 kVA frame. And in it, we have individual 100 kVA modules. And these are completely separate UPSs. Those two modules there are one UPS. These two here are one UPS. They've got their own individual battery support. A truly modular UPS, which is unique in the environment that we work in. This easy again allows us to add day 2, day 3 capacity, and we can do pay as you grow. The client can add these modules only as he needs them. And that's a complete pair of modules and a battery string that matches it. So you're not buying all those batteries on day 1. You don't need them on day 1, don't pay for them on day 1. The whole of the system is monitored with a nice colour HMI unit here, and again we've got remote network connections on all of these devices. Again, inside the individual switchgear compartment you can actually see you've got individual battery isolators, got individual module isolators, all in the same piece of switchgear. We've got a cover off there at the moment, as this is literally being commissioned as we speak. So all of this again can all be live worked. So once we've got the tails connected to the switchgear, which is just behind us, all of these modules can be changed out by a competent person. You don't need to turn off the UPS, you don't need to isolate the running modules. You can just slide in those modules. The batteries are actually, the battery tails are already connected, and the batteries themselves can just be put on the rack, which is just behind us and we'll look at in just a moment. Here we have the battery isolation. Each string of batteries can be individually isolated within this cabinet. They then connect through to the battery rack. Battery racks, in this case we've got the day 1 is so far loaded. We've got two 100 kilowatt battery strings here. These are going to give about 15 minutes of support to the IT load for the client on day 1. And then when we add in the extra power capacity for days 2 and 3, those batteries just go on these racks, and again we can do all these connections while they're alive. This customer wants battery monitoring, and every single one of these cells has got an individual battery monitor and battery computer on it. All the cells are completely balanced. That increases the lifetime of these batteries. Should be no problems with reaching 10 years lifetime with these battery bank systems. You can also see a few of the other features of our modules here. We've got a smoke extract system behind us with a fireman switch on it. We've got the overhead cableways for the incoming power. This is all built into the structure. It'll be fire glanded when we install this on site. There's also fresh air filtration. There's a G4 filter up on the wall over there. So when the smoke extract is on, that air is being made up through this chamber. And that also is used to ventilate the batteries, because obviously there is still a hydrogen gas problem, as with all sealed lead acid batteries. We've got support for all the switchgear and cabling, which is going out to the chiller systems down the end of this module. We've got the earthing for the main power systems, and again all the external plant and chiller systems, earth on the end. There's a large open space here. This is actually where the Novec fire protection bottles are going to go. And there's also enough room in this space to put in a pre-production cabinet should a client desire it, where he can put some equipment in, test it before he deploys it onto the data cabinets. Here we have the standard 800 wide, 1200 deep data cabinets. There are 10 in each one of these rows. They're all air blocked and blanked, as you'd expect in a hot and cold aisle scenario. And they've also got the water pipe work for the water cooling system running underneath. As I say, 10 data cabinets in this row. Obviously if these were 600mm wide cabinets, you could have more of them in the row. The within row units are further on down. We'll be looking at those later. Here we are in the warm aisle, back to the cabinets. We've got overhead power provision. All of the commando sockets over our heads connect back to the end of row power distribution. We've got two standard PDUs in the back of every cabinet. They're all power monitored and metered. I think there are 24-way outlets on these units. Overhead, there's also support for the customer's cabling. There's copper cable raceway over the top and a fibre cable raceway over the top as well. The client will be using probably mid-row patching in this scenario. We've got, as I said earlier, 10 data cabinets either side of me. This is the backs of them all as we run along. They're up on a raised plinth. There's a service plinth in this environment. All the water pipes run underneath the cabinets, so the water cannot get into the data cabinets. There's steel floor that separates them from it. We're actually at the back of one of our in-row cooling units. The hot air from the aisle goes into the back of this 30 kilowatt cooling unit, and the cold air is blown out into the cold aisles, which are on the other side of both these rows of cabinets. And as I say, at the very end of the row, we've got the power distribution. So this is power distribution A. This is where we can isolate the individual outlets that support the PDU A's in each cabinet, and they're easy to disconnect. You just turn them off on this, and you've isolated the A channel on your data cabinet. Here we are at the back of one of the 800mm wide by 1200mm full-size data cabinets. These are 42U high. So we've got A and B PDUs in here. We've also got cable management systems built in, every U-height marked on the cabinet to suit the client, and also a full earthing system. These are all full earthed cabinets, basically to meet what we would call a military specification, which is obviously extremely safe. We've also got air blanking, which is on the other side of the cabinet at the front. We've got 50% blanking incorporated on this cabinet. There are some air control glands which are to go in when we go to site. Every single one of these outlets is all covered with a plastic gland, again to prevent the mix of hot and cold air between the two aisles. So this is the rear of one of our 30 kilowatt, 200mm wide with in-row cooling units. This has a capacity of 30 kilowatts of total cooling, about 25 kilowatt sensible cooling depending on humidity. This takes the warm air from this aisle, runs it through a large heat exchanger, 6 fans, we've got N+1 redundancy, and it blows it out into the cold aisles, which are on the outside of either of these warm aisles. This is the permanent temporary outer wall on the second data module. On day 2, this wall is removed and put on the outside of the next data module. There's also an interior wall that will be installed when we're on site, which allows us to remove this wall on site on day 2 without altering the function of the data center in any way. So we can remove this outer wall, we can bring the new modules up against the side, we can actually commission the new data modules before we finally remove the temporary wall that will be erected inside and then enter through the rest of the white space. The permanent temporary outer wall is rated at 90 minutes fire rating. We actually use 120-minute fire rated panels to get that rating. This green film is a protective cover to stop it getting scratched in transit. And this is installed when we get to site. So the modules are delivered in their entirety, 40-foot modules, and then we erect the temporary outer walls when we get to site, because obviously they will move as we expand each data module on days 2 and 3.